Elon Musk has warned that humanity is completely unprepared for the giant solar flares heading our way with our increased reliance on technology and satellites. Increased solar activity is a massive threat to our daily lives if we do not learn to manage it now. But what exactly can solar flares do? What can we do to manage the situation? Elon Musk has the answers. An expensive storm. SpaceX has over 3,000 satellites in orbit with plans to build a sprawling Starlink satellite network with 40,000 satellites in line with that objective. 49 satellites were sent to low orbit aboard the Falcon 9 on February 3, only to come crashing down a week later. Around the same time, a wave of solar radiation and energy particles washed over our planet due to an explosion on the surface of the Sun. These eruptions, called coronal mass ejections or solar flares, reached Earth, heating up the atmosphere in the process and raising the density of the small amounts of air at an altitude of 130 miles, where the Starlink satellites were sent. Elon Musk released a statement explaining that the satellites were affected by a geomagnetic storm. 40 out of the 49 Starlink satellites were destroyed, effectively sending $50 million down the drain. Starlink satellites and other low-orbit satellites are especially vulnerable to geomagnetic storms since they are released into very low-altitude orbits and rely on onboard engines to overcome it. The force of atmospheric drag. The geomagnetic storm caused the atmospheric drag to increase by 50%, and this increase prevented the satellites from reaching higher orbits since they could not bear the drag. They fell back to Earth. The Starlink team tried to put the satellites in safe mode, but this effort was a little too late as the storm prevented 80% of the satellites from reaching their destination. The good news is the satellites' re-entry into Earth's atmosphere pose no collision risk to other satellites and no part hit the ground. Additionally, a fresh set of satellites were launched on the Falcon 9 earlier this month and were placed at a higher orbit to avoid atmospheric influences contributing to another fall. But Starlink satellites were not the only systems affected by the increase in solar activity. This year, an active sunspot about to lead the visible disk off the Sun shot a parting solar flare at Earth, disrupting shortwave radio communications in the Middle East and Africa. This occurred on September 16, affecting frequencies below 25 MHz. Space weather forecasters at the UK Met Office predict more flares from the lively sunspotter 3089 and believed that a coronal mass ejection might be heading to Earth as well following the flare. While this geomagnetic storm was small, Musk noted that we are far from ready to deal with more serious solar flares and geomagnetic storms that can have an impact on our everyday lives. Solar flares are huge explosions on the surface of the Sun emitting electromagnetic radiations like radio waves, X-rays, ultraviolet radiation, and visible light. Imagine a million volcanoes exploding at the same time. These flares occur when built-up magnetic energy in the solar atmosphere is released suddenly. They tend to occur from cooler regions of the Sun called sunspots and are intricately tied to the 11-year cycle of solar activity driven by the Sun's magnetic field. These solar flares are grouped into classes depending on the intensity of the explosion, ranging from weakest to strongest. The categories are A, B, C, M, and X. The geomagnetic storm responsible for the Starlink satellites is a small G1 class, caused by an M1 class solar flare. Another X1 flare, the most intense of them all, was spotted by NASA's Solar Dynamics Observatory on October 2, and this X-class flare might have disrupted Hurricane E in disaster response, affecting rescue workers using 25 MHz radios to communicate effects of solar flares on Earth. The first geomagnetic storm in recorded history was identified by British astronomer Richard Carrington in 1859. Carrington was investigating a group of sunspots and spotted a beam of light that lasted 5 minutes. The subsequent geomagnetic storm resulted in auroras visible from the northern hemisphere to as far south as the Caribbean. The glow from the auroras was enough to make miners believe that morning had come. People in the northern hemisphere in the United States could read newspapers with the aurora's light as the colorful lights dazzled many. The geomagnetic storm caused telegraph systems All over Europe and North America to fall spark flew from the telegraph machines and operators received severe shocks whenever they tried to use it despite the batteries being down and the machines disconnected. Some telegraph lines from New York to Pittsburgh could send messages due to the electricity and heat air called the Carrington event. This was the most intense solar flare to occur in the previous 500 years, and if it happened today with the technology that we have in place, it would affect whole continents and its effects would be felt for years. This was emphasized by researchers from the Atmospheric and Environmental Research Agency, saying that such an event today would result in close to $2 trillion in damages. But before that happens, make sure you hit the like button if you are enjoying the video and subscribe to keep up with the latest news on Elon Musk. While in most cases the effect of solar storms results in dazzling displays of aurora, powerful storms can do much more, like taking down satellites in their entirety. It can also throw out our ability to accurately predict the positions of objects in low Earth orbit using radar measurement. The Space Surveillance Network tracks down the location of defunct spacecrafts and debris, ensuring that satellite operators like SpaceX receive timely warnings when their satellites are in proximity of space debris. But this cannot happen during a powerful solar storm, according to solar physicist and director of the Space Weather Technology Center at the University of Colorado, Tom Berger. In the largest storms the era is in, the orbital trajectories become so large that essentially the catalog of orbital objects is invalidated. Objects can end up kilometers away from their initial location, and may remain lost until they are found again using radar. Most people are gradually becoming aware of this phenomenon, but the Earth is no stranger to the sun's wrath. In 1972, a major solar flare knocked out long-distance phone communication across several states, causing it to redesign its power system for transatlantic cables, and Canada. 6 million people were left without electricity for 9 hours due to a geomagnetic storm. The solar storms of 2003 now doubted. The Halloween storms of 2003 caused aircraft to be rerouted, affected satellite systems in and caused power outages in Sweden. The current solar cycle 25 is intensifying as it approaches its peak in the next 1 to 2 years, and scientists are warning that this could be the most active one since record-keeping started in the 1700s. This is what it means for us. The sun's activity in solar events will increase between 2023 to 2025 and will affect the technology here on Earth, our communication systems, as well as the satellites and astronauts in space. Electric power grids and national systems will be disrupted. The impending solar storms in space weather will drive intense electric currents, causing damage to important infrastructure. Expensive power outages and high costs of repair and maintenance during this time. Near polar regions might experience high fluxes of radiation in the form of energetic particles. These particles can travel to low altitudes and may become a source of concern for airplane flight crew in passenger helm. The only upside to the current cycle 25 is the impressive auroral displays we'll get to see, but is there a way we can manage it?